Kiddos, welcome to this week where we are talking about triangles and continuing to build on what we know about angles. So our first page is asking us to determine if the three side lengths can or cannot form a triangle and prove it with inequality statements. So we learned in class that the sum of any any two sides needs to be greater than the one that is remaining. If that is true, if they all work out, then it is a triangle. If not, then it cannot be a triangle. So what I'm going to do is I'm going to label these A, B, C, because we learned in class that A plus B should be greater than C. Now, I know that I need to mix and match these because I have to test all of the relationships, but I think that it might help you see it just a little bit. So I'm going to start with A plus B needs to be greater than C. So is 11 plus 3 greater than 12? Yes, that checks. Now I'm going to switch the relationship. I'm going to do 11 plus 12 is greater than 3. Is 11 plus 12 greater than 3? Yes. Last relationship that we need to test is the 12 plus 3. Is that greater than 11? Yes. So this would form a triangle. We're going to do the same thing over here. So we're going to do 19 plus 9 is greater than 8. Yes, that's correct. 19 plus 8 is greater than 9. Yes, that's correct. 9 plus 8 is greater than 19. This is not correct. That would be 17. So no, this would not form a triangle. 7 plus 19 is greater than 12. Yes. 7 plus 12 is greater than 19. No, they are a match. 7 and 12 is 19. So no, this one will not make a triangle. Over to here, A plus B is greater than 11. Yep. A plus B is greater than 10. Yep. 11 plus 10 is greater than 24. No, that would only be 21. So no, this would not make a triangle. 2 plus 7 is greater than 7. Yes. We could flip them, but we know that 2 plus 7 is still greater. 7 plus 7 is greater than 2. Yes, these check out. So yes, this is a triangle. Last one, 16 plus 6 is greater than 11. Yes. 16 plus 11 is greater than 6. Yes. 6 plus 11 is greater than 16. Yes, this would make a triangle. So again, if you need the reminder, your formula is A plus B is greater than C, but we have to test all of our relationships. Any questions? Bring them with you to class. So a little bit of a refresher. I know that we had a little bit of trouble with building on our skills. So I did just want to make sure that we kind of brought this back just a little bit to make sure that we were still understanding these. If you need any help, this was in that triangle photo dictionary that I gave you. And if you lost it or you can't find it or you'd like a copy of it, please let me know. So we're classifying the triangles by angles and sides based off of the information below. So let's go through and do them by angle first, okay? So this one has a right angle. This is going to be a right triangle. Looking just at angles. All three of these are acute, so we're going to say this is an acute triangle. Just based on angles, this would also be an acute triangle. Based on angles, this would just be an acute triangle. This one's acute. And this one is obtuse. Okay, so we have our names based on angles done. Now we need to go back and do our sides. Remember that these lines mark up similarities, and we're looking to see if they're equilateral, scalene, or isosceles. As a reminder, equilateral has 3 equal sides. So this one right here would be equilateral. All 3 signs are matched with the same number of lines. Coming down to this next one, I have 2 matching sides. I have 2 eyes. This is isosceles. So 2 matching sides, isosceles. So this one also would be isosceles. Sorry, that should be an S. Here we have all 3 different sides. If they're all 3 different sides, it is scalene. So this would be a right isosceles. This would be acute equilateral. This would be acute scalene, and this would be acute isosceles. These last two, we need to take a peek at what we see. This one, all three of these, I would consider the same. So I would say that this is equilateral, acute equilateral. These, I have all different sizes, and they would be scalene, and you can measure them if you'd like to double check it. Any questions on these? Please bring them with you to class. All right, so we are defining the term and drawing an example of the triangle. So if I drew a right triangle, we would have one right angle, and the definition is that one angle is 90 degrees. That's what makes it a right triangle. If it's equilateral, drawing an example, all three sides are equal length. Okay, coming down here, an acute triangle. All three angles are less than 90 degrees. Remember, for acute, all three angles need to be determined. Scalene has three different sides. So all three lengths are different. For an obtuse triangle, that is a horrible example, but you get the point. One angle is greater than 90 degrees. So for obtuse and right, one angle makes the choice. For acute, all three need to be determined. Isosceles, two eyes, two sides have to be the same. So two sides have an equal length. Any questions on these? Bring them with you to class. All right, love bugs, for this one, I was hoping that we would practice with a protractor. If for some reason you didn't have a protractor, that is okay. But I was hoping that we would be able to do that. So what you needed to do was measure the interior angle with a protractor and then use that to determine the outside angle, knowing that a straight angle has a total of 180 degrees. So when we see these lines, we know that that's a straight angle. Straight angles have 180 degrees, okay? So if you measured angle two is 60 degrees. If angle 2 is 60 degrees, then what is missing? 120, because 60 plus 120 gives me 180. If you measured C, it was 50 degrees, which means the missing portion is 130, because 130 and 50 give you 180. A is 90 degrees, which means we also are missing 90 degrees. I is 30 degrees. What's missing? 150 degrees. 3 is 45 degrees, which means that we are missing 135. And B is 75 degrees, which means we are missing 105. Again, measure your inside, determine what's missing by subtracting that from 180 degrees. Any questions on these? Bring them with you to class. And then our last one, finding the missing angle. We have talked about this last week, but our equation for a triangle is that it has 180 degrees, right? We talked about unknown polygons being n minus 2 times a triangle. Since we already have the triangle, we know that it's 180 degrees in total. So I'm going to add up the amounts that I have. 90 plus 60 gives me 150, which means my missing angle is 30. So add what you have, subtract it from 180. When I add 50 and 55, I see that I'm missing 75. When I add 115 and 40 together, I see that I'm missing 25. When I add these together, I see that I'm missing 60. This is an equilateral triangle and acute. All of them are the same size. We talked about this type of triangle. You might not have even needed to do it, but we know that if we have 90 degrees and 45 degrees, that missing angle is 45. And then we have a 70 degree, and a 40. Any questions on the homework or anything that we've talked about, please bring them with you to class. Have a good weekend, Math.